Hello friends, today we will discuss about the production or origin of X-rays part 2, that is characteristic X-rays. Last time I have discussed about the continuous X-rays. I have told you last time that whenever fast moving electrons collide with a target material of high melting point and high atomic number, X-rays are produced. But exactly what happens after collision? Let us discuss the second part of it. So this is the Coolidge tube that I have discussed last time, that fast moving electrons will strike a target material and X-rays are produced, and this I have discussed in detail in my last lecture. So today I am going to discuss about the second part, that is characteristic X-rays. The same target material is used to produce the characteristic X-rays, which was used to produce continuous X-rays. So from the same target material, whenever fast moving electron will strike a target material, continuous as well as characteristic X-rays are produced. Now let us see how these X-rays are produced. Now for example, there is one electron and this electron will collide with the electron of the K shell. Now this is K shell, this is nucleus, this is L shell, M shell, and so on. There will be many electrons. Now suppose one of the electrons will strike the electron of the K shell and this electron is displaced from here. Therefore vacancy will be created here, a hole will be created here. So this atom will become unstable. To make it stable, the electron from the upper shell, that is from the L shell, will fill this vacancy. That is, electron from the upper shell will fill this hole, so there will be transition of electron from upper shell, in this case from L shell to K shell. Because there is transition of electron from higher shell to lower shell, there will be release of energy. Now for example, how there will be release of energy? Now for example, this is our K shell and this is our L shell. Now for example, the energy of this shell is 1 electron volt and energy of this shell is 3 electron volt. This is just for the example. And to de-excite the electron, suppose there is electron placed here, to de-excite the electron from this shell to this shell, this electron will have to lose energy 3 minus 1 electron volt, that is 2 electron volt. Now this energy will appear or may appear in the form of radiation. Now in this case, whenever fast moving electron strike the electron of K shell, and vacancy will be created. To fill this vacancy, electron will come from upper shell, maybe from the L shell, to fill this vacancy. So there will be change in energy, release in energy. So this energy will appear in the form of radiation, and in this case the radiation energy is equal to the energy of X-rays. Now here H is Planck's constant, nu is the frequency of the X-rays. So this is given as EL, that is energy of the L shell, minus EK, that is energy of the K shell, and this equals to H nu. Now I will write here as H nu K because whole of the K shell will be filled, and I will write here as alpha also because the electron is coming from L shell. If the electron will come from M shell, we will write here as H nu, and this M shell electron, if it will fill the whole of the K shell, then it will be written as H nu K beta, and so on K gamma. So if I will try to discuss the energy level diagram of this transition, so it will be like this. It will, suppose this is K shell, this is L shell, this is M shell, this is N shell, this is K. Now first of all, this is K, L, M, N. For example, there is hole in the K shell. To fill this hole, electron can come from L shell, may come from M shell, may come from N shell, and so on. So we will write here as K alpha, K beta, or K gamma. Now for example, if there is hole in the L shell, to fill this hole, electron will definitely come from the upper shell. So we will write here as L alpha, or if it will come from M shell, L beta. Now for example, if there is hole in the M shell, then electron can come from upper shell, that is N shell in this case, then M alpha. So this is the energy level diagram for continuous X-rays. I hope you have understood that how characteristic X-rays are produced. Why these are known as characteristic X-rays? Because each target material has its own energy level diagram, has its own characteristic energy level diagram. So that is why it is known as characteristic X-rays. So this is the graph between X-ray intensity produced and the X-ray energy. So both type of X-rays are produced from the same target material, that is continuous, that is Bremsstrahlung long, that I have discussed in the last video lecture, and the characteristic X-rays. For the characteristic X-rays, there will be peaks, that is K alpha peak, K beta peak, and for the continuous X-rays, there will be continue graph. This is our continue graph, and this is the position of lambda minimum. I have discussed in the last lecture. Please refer that last lecture. So this is the graph between X-ray intensity and X-ray energy. So my dear friend, I hope you have understood the production and origin of both continuous that I have discussed in the part 1 and characteristic that I have discussed today. So please subscribe, like our channel, and share it. Thank you. Thanks a lot.